Okay, this is our lesson on generators. We've got to talk about the two types of generators, which in our case are called the alternator and the dynamo. We've got to know their basic parts. We've got to think about how we'd increase the current produced and really know why each of the particular types of generator produces either alternating current or direct current. Okay, so first up, let's look at a really sort of straightforward animation of how a simple AC generator works. And at first look, you might think this looks very much like the motor that we've already looked, and that's because it is really, it's exactly like the motor. But rather than the motor being turned by an electric current, we're going to provide the movement and see if we can generate an electric current. So we've got a coil of wire in a magnetic field, okay? Now, if that coil of wire in the magnetic field starts to turn, so if we push it, because remember with a generator, something would have to push the coil round. And if this is in a power station, it might be steam pushing it round, or if it's in some kind of a waterfall, it might be the water pressure pushing it round, but something is pushing it round. So if we have a look, when this coil rotates, if we imagine it in this position, the arrows are showing you which way it's going round, we can see that the coil of wire cuts through the magnetic field lines, and as the coil cuts through the magnetic field lines, that's exactly what creates the electricity, or this is what induces the voltage, as we would say. So as it's cutting through the field lines, it's inducing the voltage, and you can see on our little milliammeter here, because we've got a complete circuit, we would have a positive current. All right, so the main components, the coil, the magnetic field, and we've got this thing here, the commutator. This is called the slip ring commutator, and there's two separate circles that are conductors which are connected to the coils and the wires, and this allows the electricity to flow. But bear in mind here, there are two separate coils. There's not one coil with a gap in it, and that's coming up in a second. There's two separate circles, sorry, not coils, two separate circles or rings, and these rings are connected to the ammeter, and each of the ring is connected to one side of the coil, and you can see it's color coded to be like a browny, orange and a green color. All right, so as it's spinning, it cuts through magnetic field lines and it generates a current. At this point, we can see that it really is, if you imagine this coil rotating, it's cutting through the most magnetic field lines. So here we've got the most current being generated. So the more lines it cuts through, or the more rate of flux cutting, if you've had that word in your lessons, magnetic flux means the magnetic field lines, then the more current you get. So this is where the current would be a maximum. As it continues spinning, if we imagine at this point, it's going to get to the point where it's horizontal. Now at this point, notice the ammeter has gone to 0, and this is because the coil in this position is not cutting through any of the field lines. So here we would say the flux cutting, or the magnetic field lines being cut, is 0, so therefore the induced current is 0. So in this position, it's gone from positive all the way back down to 0. Now as we go past this point, so you can see it's gone round another sort of a little bit of a rotation. Have a look on the meter and you can see we've gone negative, and this is because the coils are the sides of the coils are cutting through the magnetic fields in the opposite direction. So this green side was cutting down here, whereas now the green side is cutting up through the field, and that means that the current is going to be produced in the opposite direction, and we could work that out thinking about our kind of left hand sort of rule. All right, but you don't need to go into that amount of detail. All you really need to have in your heads is that as the coil cuts through the magnetic field, that produces a current, and this current that's being produced, because it's connected via this thing called the slip ring commutator, then that current is an alternating current. And the thing we've got to think about in a second is, what if we change the layout of this these slip rings, or this commutator here? All right, but just to see this in full work, or fully working, you can see now that our coil is rotating, and as it goes one way, so if you imagine one side of the coil, as it cuts through the magnetic field lines one way, we get a positive current, and then as it cuts through the other way, we get a negative current. And the maximum current is being produced, if you look at this graph of current down here, the maximum current about now is when the coil is horizontal. Minimum now, yeah, maximum now, and it's when it's horizontal it produces the most electricity. And even though I'm saying minimum a minus 100 amount of milliamps, then that's still obviously an amount of electricity, even though it's minus. Now the 0 value now is when the current is when the coil is vertical now. Yeah, so if we look at the graph and look here, and when that crosses the 0 line, this is, if I stop it there you go, it's just heading towards the 0. And then maximum, when it's horizontal, heading towards the 0, and then maximum. Okay, now the question to ask is, what if we change the design of this, and instead of having 2 slip rings, we had a split ring, more like in our motor. So if we just look at the next picture here, and you can see, if you look carefully on this little animation I've got, this now is connected, the sides of the coil are connected to one ring, but there's a gap in it, just like in our motor. So occasionally what happens is the sides of the coil are connected to these different wires here. So this sort of swaps over which it's connected to. Now because of this, rather than get a positive than a negative current, we permanently get a positive pulses of current. So no matter how it spins, we get a positive pulse, a positive pulse, a positive pulse. It's effectively converting the negative bit into a positive. Alright, so this is not a slip ring commutator, this is a split ring commutator, and this will produce direct current. This would not produce an alternating current, this is a direct current. Now we would call this a dynamo. The previous one is an alternator, and this picture would be a dynamo. So I've got 2 slightly better pictures here. This is the alternator, and if you have a look, the alternator has got slip rings and it produces alternating current, whereas underneath I've got a picture of a dynamo. It looks very similar, but the only difference here is that this is now a split ring commutator, and this will produce direct current. Okay, and if you think about the graphs for the first one, the graph for the alternator will be an alternating current going positive and negative. The graph for the dynamo would just be a graph that's going effectively positive. Okay, so if we just move on a little bit, let's just see if we've got all this. When a conductor cuts through magnetic field lines, a potential difference is induced across the ends of a conductor. If there is a complete circuit and electric current flows, this is called induction, or the generator effect. Okay, generators rotate a coil in a magnetic field to produce electric current, and here's the main difference between the two. Alternators use slip rings to generate alternating current. Dynamos use split rings to generate direct current, and the name gives you a clue that alternator is alternating current, with a D, dynamos is direct current. Okay, and you need to be able to explain where the current produced is a maximum in both types of generator. And remember, it's a maximum current when the sides of the coil are cutting through the most magnetic field lines, and that's when the coil itself is horizontal. Okay, and just the last little bit, have you look at this diagram here. We've got a split ring commutator, so this must be producing alternating current. Look at the diagram of the generator. Explain whether the voltage produced at this point is a maximum or a minimum. So here we can see the coil is vertical, it's not cutting through any of the field lines, so it must be a minimum, and the reason being is that, as I've said, the coil is not cutting any of the magnetic field lines as it rotates, so the voltage produced is 0 in this position. And next up, the trace below, this trace here, shows what happens when the generator is spun 5 times a second. Complete the diagrams below, the 2 graphs below, to show what happens when the changes are made. So this is 5 times a second. You can see it goes all the way up and all the way down in 0.2 seconds. So if you imagine in 1 second, this will go all the way up and all the way down 5 times, because 5 times 0.2 is 1. So number of turns on the coil is doubled. If we have a look, if we double the number of turns on the coil, we're going to get twice the amount of voltage induced, but our wave is going to have the same time. So it's still going to be 0.2 seconds for 1, but it's going to go twice as high. So instead of going to 5 volts, it's going to go to 10 volts. So you can see here I've showed this sort of curve that's going up to 10 volts and down to 0, minus 10 volts, back to 0, and that happens in 0.2 seconds. Because remember, we haven't changed how fast it's spinning, we've just changed the amount of turns on the coil. Okay, for this graph, we've now got the generator spun 10 times a second. So here we haven't got twice the amount of turns, we've just got it spinning twice as fast. So we're still going to get twice the amount of electricity produced because it's cutting the flux lines or it's cutting the magnetic field lines twice as fast. But we're going to have it happening in a different wave here because this is taking 0.2 seconds for one wave, whereas if we spin it twice as fast, here it's just going to take 0.1 seconds for one complete wave. So if you have a look here, I'm twice as high, up to 10 volts or thereabouts, and I'm dropping down, I'm going across twice as fast. So it goes from plus 10 to minus 10, but it does all that in 0.1 seconds. So you can see this is the effect of spinning it twice as fast. All right, so that's what you've got to do. You've got to know the difference between the alternator and the dynamo. You've got to know the difference in terms of the slip ring and the split rings, and then you've got to know that which produces alternating and direct. So the alternator is alternating current, the dynamo is direct current. And then to really show your understanding, questions like that are on this little screen here, that will show that you appreciate when the voltage is maximum and minimum and what happens when we increase the amount of turns and increase the rate of spinning.